my KCET 2026 champions. So I hope all of you are doing really good and working hard towards your dream, that is getting a top rank in KCET 2026. So welcome to the Sankalp batch. So students, in our this journey we have till now covered the electrochemistry chapter, the KCET PYQs, and today we will be going a little bit a step ahead, one level up, and we'll try to solve JEE PYQs. So see, I know many of you are preparing for KCET, but definitely students write JEE to just have some students prepare for it seriously and some students also write it. But we have to check that whatever concepts we have learned for KCET, can we use that to solve the JEE PYQs? If yes, then why not give a try, right? So solving difficult questions or solving more questions will only give you better practice, and there is nothing wrong in that, or there is nothing loss in that, or it is not a time waste. Okay, so please don't think that I am giving KCET, why should I do JEE PYQs? You should do, because the competition is increasing, right? Last year if you see, the cutoff has gone, even the top marker students got very low rank, right? Like as compared to their expectations. This is because competition is increasing. So definitely next 2 years question paper will be tougher, like it will slowly go towards the tougher side. So we need to improve our skills, right? So that is why we will also solve KCET PYQs and some other JEE PYQs which can be solved with what we have studied for KCET. We don't have to do any extra effort, just the concept we have to apply it in a different way. Okay, so that was the purpose of adding this JEE PYQ, so that you will be preparing little bit more like strong, you'll be more confident about a particular topic. Clear? So now I have this particular slide is a new introduction where we will be celebrating all those students who replied or who answered the comments in the last video. Okay, so last video was KCET PYQs. So we have here some list of KCET winners. So these are the students who have put their efforts, put the comments in the comment section, they have answered it. So it was really a very pride moment to think that okay, these students are understanding what I'm teaching, they're answering, they're responding to what I'm saying. So I'm really grateful to all these students. So I really want to praise you in front of everyone, so that many students get motivated and show their participation. So here I'll be taking the name of first one student who is very consistent from the first video itself, from the bridge course video itself, that is Prajwal King DC. Okay, so I hope your name is Prajwal. So Prajwal has given me the answer of question number 3, question number 4. So it was when the video was starting, and he has shown immense participation, and I'm really happy. And these messages have really like something which tells you makes your day. It is like that. And I have one more student who has answered very nicely, that is Nitin Reddy. Okay, so fuel cell, I have given a question which was in between the lecture, so that also he has answered. And I think this was AL203 was answering for something. So this student has also shown like replies to whatever I have asked. So the students here, Nitin and Prajwal, very congratulations to you. And I also motivate other students to join like this and show that I can know you, I can know your names, and I can put that in this, and I want this to be fulfilled with like all your comments, and I will be taking each and every comment that you have given me. Okay, so that's all in this section. So this is a new section that we have introduced, and we will be continuing it for the next all videos. And I'll be taking like which student has a attendance throughout all the lectures. So there will be almost 100 to 150 lectures in covering all the chapters of PU1 and PU2. So let me see which student is consistent with me through the whole year. Okay, so now we will be ending this and we'll be directly moving to our topic, that is electrochemical cells and galvanic cell. So electrochemistry, you know, it has a lot of topics. Okay, so we will be doing question topic wise so that we know which topic we are strong at, which topic we are little bit weak, and we need to revise. So let's see the first question here. The standard cell potential, okay, of a fuel cell based on the oxidation of methanol in air has been used to power television relay stations is measured as 1.21 volt. So you know, fuel cell, you can use the combustions generally of hydrogen or combustion of methanol, methane we can use. So similarly here in a fuel cell, a particular fuel cell, we have used the combustion of methanol, and in that the power produced was 1.21 volt, not power, I can say the standard cell potential. The standard half cell potential for oxygen is 1.229 volt. For oxygen, this is the potential value. Choose the correct statement. So do we remember, this is very basic question of 3rd April 2025. I want all of you to take 1 minute pause and just try to solve this question. So the options given are: the standard half cell reduction potential for the reduction of CO2 is 19 millivolt. We have oxygen is formed at the anode. Reactants are fed to go to each electrode. Reduction of methanol takes place at the cathode. So if you remember, now I want all of you to take 1 minute pause and answer, and then unpause it and then see the solution. So if you have remember fuel cell, we have studied in the last part, right, part 5 of the electrochemical cell series. There if you see, we have studied about hydrogen oxygen fuel cell, and I have told you that hydrogen is taken at anode, okay, and oxygen is taken at cathode, right? Now here also we have oxygen, so definitely oxygen will be taken as cathode. Now what will be taken instead of hydrogen here? In this question we will take methanol instead of hydrogen, right? We'll be considering methanol. So oxygen is formed at anode, is it correct? No. Reduction of methanol takes place at the cathode? No. Methanol is taken at anode, so this is also wrong. Reactants are fed at one go to each electrode. So if you remember, hydrogen oxygen fuel cell, the reactants are fed continuously, not at one go. So this is also incorrect. So without calculation also you can say that option A has to be correct, because B, C, D are incorrect. But let's find it out. So what is the E naught of the cell? So I can write E naught of the cell will be equal to E naught of cathode, which is oxygen, right, minus E naught of anode, which is methanol, right? So what is the E naught of the cell value? 1.21 volt, right? So 1.21 minus, sorry, equal to, cathode is 1.229 minus X. Okay, this I have to find out. So what will be this value? X value will be 1.229 minus 1.21. So I'll get 2 minus 1, 1, 2 minus 2, 0, and then I'll have this much, 19 volt, okay, 0.019 volt. So if I want to convert it into millivolt, it is equal to 19 millivolt, right? So option number A is the correct answer for this question, right? Very simple and easy question. So see, even if you have studied only for KCET, still we can answer this question, right? Yes. Let's move to the next question. Okay, next question we have here. Based on the data given below, you have been given with the reduction potentials of Cr2O7C, Cr3 plus, Cl2, Cl minus, MnO4 minus, Mn2 plus, Cr3 plus and Cr. The strongest reducing agent is. These type of questions are asked even in KCET exam, okay? Strongest reducing agent. Now see, reducing agent means what? It will reduce others, right? Reducing agent, it will, this X, suppose this is the strongest reducing agent, okay? So what it is doing? It is reducing others. If it is reducing others, then can I say that itself it is undergoing oxidation? Itself it is undergoing oxidation, right? If it is undergoing oxidation, it means its reduction potential should be least That means reduction potential should be least. Once again I will repeat, we want strongest reducing agent, means it will reduce others. Itself it will undergo oxidation. Oxidation, if it is going, means if I have 4 options, the one whose reduction potential is least, that will have the highest tendency to undergo oxidation, or that will be undergoing oxidation best. So if that is the best one which is undergoing oxidation, its reducing agent will also be a stronger one, strongest one. So I can say that where the reduction potential is least, here. Right? So that means if you see which will undergo reduction easily, this one will undergo reduction easily. First it will undergo reduction, then this one will undergo reduction, then this one will undergo reduction, then this one will undergo reduction. Least reduction, but oxidation, this one will be the first one to undergo oxidation. So it will be the best reducing agent. But now which one will undergo oxidation? See, chromium 3+ is there. Right? Chromium 3+ will undergo reduction. Chromium will undergo oxidation if I see in this direction, right? So if chromium is undergoing oxidation, chromium will behave as a reducing agent, not Cr3+. So the answer here will be chromium. So sometimes in the question, Cr3+ can also be given as an option. So you have to be very, very careful. Which species is undergoing oxidation? So if you see, these are all reduction potentials. Chromium 3+ to chromium has the least reduction potential. That means it has the highest tendency to get oxidized out of these 4. If this is undergoing oxidation, it will behave as a very good reducing agent, right? But which one, Cr3+ or Cr? It is Cr. Okay, I hope this is clear. So next, okay. So before going to the next questions, I hope you are enjoying till now. You have answered both the questions correctly. If yes, please put down a comment section quickly. And now let me tell you that you might be thinking that is this channel reliable? Can we trust blindly on this channel for our preparation? Can I trust Aishwarya Mam for my preparation in chemistry? Can she get me 60 or very good marks or 60 out of 60 in KCET chemistry? So yes, this doubt should be there, and this doubt, like this concern in your mind is very, very relevant. But you can trust us because we have produced results across the years. Okay, so I'll be showing you the last year 2025 YouTube channel toppers here. So you can see here Prajwal S, we have Kiran Kumar, Diksha C, Samiksha, Sachin. So these students, and then we have Harshit, Chinmaya, Tanmaya, Mohammed, Kirtana. So these students have some or the other way connected with YouTube. They have taken our test series, or they have taken our lectures. They have studied from us. Okay, and if you see their interview with us, we have called these, or Diksha was there with us, Prajwal was there with us to meet us. So if you talk and just see their interview, you can understand how reliable is this channel. And you can see the content also, you can see. So that's why where you can trust us, you can just follow this channel, follow chemistry from here, so that you can get the best marks in KCET examination. Okay, and I want all of you are studying from here, from this channel, to be in KCET 2026 toppers list. And I want this should happen from all those students who are watching this channel, because we are providing the best content that is available. So please, and there is nothing to pay. It is just, you just need to hit the subscriber button. You need to be regular throughout the year. You need to attend all the classes, do all the homeworks, and do all the lectures, right? That's all you have to do. And consistently, if you do every day, all the classes, syllabus, questions, practice, revision will be done on time. Right? So I hope you will be doing this, and if you are ready to become a champion for KCET 2026, please put down in the comment section. Let's see the next question. The standard reduction potential values of some of the P block ions are given below. Predict the one with the strongest oxidizing capacity. Again, this question is very similar to the previous one, and if your basics are clear, we are going to answer it very easily. Strongest oxidizing capacity. The previous question was strongest reducing agent. Here it is asking strongest oxidizing agent, right? So if it is having strongest oxidizing agent, okay, then what will happen? So that means it is undergoing oxidation better. Sorry, one second. If it is strongest oxidizing agent, it is oxidizing others. Itself, what it is going? Itself, it will do reduction, right? Itself, it will undergo reduction. Means the one which is undergoing reduction best, that will be the best or the strongest oxidizing agent. So for itself reduction, we should have highest reduction potential, right? So we can see here where we have highest reduction potential. This is 1.15, 1.67, 1.66, 1.26. So definitely this is the highest value. So option number B is my correct answer. Okay, let's move to the next question. For the given cell, the standard cell potential of the above reaction is, this question is slightly, I'll say, different from what we have studied from KCET, but such questions can be expected in KCET also. So I'll teach you how to do. So we have Fe2 plus to Fe3 plus, Ag plus to Ag. So I can see the standard cell potential will be what? E naught of cathode minus E naught of anode, and which is cathode where the reduction is happening, and which is anode where oxidation is happening. So can I write that the E naught of this cell, E naught will be equal to E naught of, so I can say, see, this is oxidation and this is reduction, right? So this is cathode, so E naught of Ag plus to Ag minus anode, that is E naught of Fe2 plus to Fe3 plus. Okay, so this is the E naught value. Okay, now if you know that this Ag plus to Ag value, so to now solve this one, we need something called as Latimer diagram. Okay, so I'll tell you how to do it. So we will talk about Latimer diagram. Very simple one, you don't have to worry. So what I need, see, you need Fe plus 3, Fe plus 2 and Fe. So I have plus 3 to Fe data, plus 2 to Fe data, and I need this data, right? So what you have to do is, suppose this one is, I'll write reaction 1, this is reaction 2, and suppose this is reaction 3. Okay, so what you have to do is, I'll just number it in a different way. This will be a little confusing. I'll use Roman numbers, okay? Okay. So this is reaction 1, this is reaction 2, and this is reaction 3. Now what I can say is, see, that reaction 1 is the sum of reaction 2 and reaction 3. Reaction 1 is the sum of reaction 2 and reaction 3. Okay. So what you have to do, the simple formula, that this one, N, I'm writing for this one, okay, N1 E1 will be equal to, this is reaction 2, N2 E2 plus N3 E3. Okay, this is N2 E2, this is N3 E3. Okay, now what is this N1, N2, N3? N1, N2, N3 are the electrons involved in that particular transition, and E1, E2, E3 are the potential difference. So what is N1 in this? Plus 3 to 3, this is 3, then you have E1. Okay, N2 from here, plus 3 to plus 2, that is 1. Okay, and what is E2 value? Plus 3 to plus 2, I have to find out that, so I'll put it as E2. Next, N3 here, plus 2 to Fe, so here N, this is 1, right? N1 is equal to, or N2 is equal to 1. Here N3 is equal to plus 2 to, so this is 2, and here I have N1 is equal to 3, right? So I have 3 E1, 1 E2. What is N3 here? Number of electrons involved, that is 2. So I have 2. But do I have E3 value? That is what? Fe plus 2 to Fe? Yes, Fe plus 2 to Fe value is Y. right? And can I also have E1 value, which is Fe plus 3 to Fe, plus 3 to Fe, that is Z, okay? This is Z. So what is E2 value now? E2 value is 3Z minus 2Y, okay? 3Z minus 2Y. Now can I solve this one here? What is Ag plus 2Ag? This is X, right? Minus Fe plus 3. So I have calculated E2, which is Fe plus 3 to Fe plus 2. This value is how much? 3Z minus 2Y. So that will be equal to X minus 3Z plus 2Y, okay? Or you can write X plus 2Y minus 3Z. So option number A is my correct answer, okay? I hope you have got it. Just check this once. You just need to find this one properly. Once you have found this, you can solve this question. Moving to the, if this question is clear, please put a thumbs up, and let's move to the question number 5. So here there is a question is given. Again, it is similar to your Latimer diagram. In the above diagram, the standard electrode potentials are given in volt. The value of EFeO4 minus to Fe2 plus. So again, similar. Now I want all of you to pause this question and try by yourself, because we have just discussed a similar Latimer diagram based question. So I'll be doing here, you also do that, and let's see who gets the answer first, okay? Let's compete here. Okay, so I have here FeO4 minus, and that gives me Fe3 plus, okay, and then I have Fe2 plus. See, this part you are not worried about, because the question is asking from FeO4 minus to Fe2 plus, means only this much I am worried about. This potential I have to calculate. Now this potential is already given as 2 volt, and this potential is given as 0.8 volt. Right? Apart from this, what is the number of electrons involved here? So if you calculate the oxidation state of Fe here, it is plus 6, right? Plus 6 to plus 3, here N is equal to 3, okay? And how much plus 3 to plus 2? Here N is equal to 1. Now plus 6 to plus 2, here N is equal to 4, okay? So this, let this be N1, N2 and N3, right? Okay, so now can I write the equation? N1 E1 is equal to N2 E2 plus N3 E3, okay? Now what is N1 here? N1 is 4, okay? Then what is E1? E1 I have to find out. Next, what is N2 here? 3. And what is E2? This is E2, so that is 2 plus, what is N3? 1, and here E3 is 0.8. So I'll get 6.8 E1 4, right? So E1 will be equal to how much? 6.8 by 4. So if I just solve this, 4 ones are 4, 2, 8, 1.7 I'll get, right? So that is option number B here. Okay, I hope this is clear. So who solved first, you or me? Fine, let's move to the next question. I always want all my students to go much ahead than me, okay? Standard electrode potentials for a few half cells are mentioned below, okay? So E0 values are given. Which of the following cells give the most negative value of delta G0? Okay, most negative value. So what is delta G formula? Minus NF E0, right? We want the, means maximum negative value should come, a very high negative value should be there. That means I can say that if E0 value is very high, then this value will be more negative, right? And E0 value should be positive and should be very high. In that case, I'll get a maximum negative one, because if this is positive, overall I'll get a negative value, right? So let's calculate the E0 value for all of them. For option number A, we have Zn and silver combination, Zn and silver combination, right? So this is magnesium, sorry. Yeah, so I have Zn and silver combination. Silver is the cathode and Zn is the anode. So what I will get? 0.8, right? 0.8 minus, that is the cathode part, minus 0.76. So that will give me how much? 1.56, positive 1.56. Clear? That one I got once. Next, calculate the second one. Silver and copper, right? I have silver and then I have copper. So 0.8 minus 0.34, right? So this one will give me how much? 10 minus 4, 6, 7 minus 3, 4. So 0.46 will be the option here. Next, option C, we have magnesium and zinc, right? Magnesium and zinc. So if I see here, minus 2.37, that is the magnesium one, minus 0.76. So that will be 2.37 plus 0.76. I just subtract it. Yeah. So I got how much? 1.61, but this one will be minus 1.61. Okay, now coming to option number D, you have magnesium and silver. Magnesium is minus 2.37, okay, and I have silver is 0.8. Okay, so if I add this one, it will be 3.37, right? So we need most negative. In these two cases, what will happen? The E naught value is itself negative. If I put a negative E naught value, delta G will become positive. So in option C and D, I am not getting. And if I now compare option A and B, right? So out of A and B, I'll get, here it is 0.46 and here I'll get 1.56, which is maximum positive. So it has to be option number A. Clear? So please check the calculations once again, and if it is clear, put a thumbs up, and let's move to the next question, that is question number 7. Okay, so for a magnesium Mg to Mg2 plus and silver to silver, the correct Nernst equation is, very simple question, a 29 January shift 1 question, such an easy question this one. So first what we will do, we will write the reaction. What is the reaction at anode? At anode, we'll have oxidation. Magnesium is undergoing oxidation. So what will happen? Magnesium will lose 2 electrons and will be oxidized. Next, we have at cathode. At cathode, what will happen? Silver is there. That will gain electron to become silver. Okay, now we can multiply, the number of electrons should be same, so multiply this with 2. Now can we add this both? If I add both, I'll get magnesium plus 2Ag plus, okay, magnesium plus 2Ag plus, this will get cancelled. You will have magnesium 2 plus 2Ag. Okay, done. Now can we write the Nernst equation? So what is Nernst equation? E of the cell is equal to E naught minus 0.059, or you can write according to the question. I'll put what is there according to the question. RT by NF. What is my N here? 2. RT by NF Ln product ions divided by reactant ions. Product ions I have Mg2 plus, right, and reactant side I have Ag plus, right, but here there is a coefficient that you should not forget. Okay, now can I have any option here? First, here this is plus, so I'll not check that. Minus, here there is Ag plus in numerator. Minus, here I have Mg2 plus, Ag plus, but the square is missing. Here I have minus, but Ag plus is in the numerator, so this is also incorrect. Then how is this correct? Is this correct? Yes. How? So what we can do is, we can just rotate it, means we can just reverse it, sorry, not rotate. So if I reverse it, what I will get? RT by 2F, I can write this is like ln of Ag plus divided by Mg2 plus Ag plus square, a minus 1 I'll put. This minus I can take this side, right? So E naught plus RT by 2F, you have ln, and we have Ag plus square divided by Mg2 plus, right? So I got this answer. So this is So if this is a KCET examination, directly this option will be given to you. Since this is JEE examination, slight twist will be there in every question. Okay, so we can answer option number A here. I hope this question is clear to all of you, my children. If yes, put a thumbs up and let's move to the next question. Question number 8. Okay, so what pressure of H2 would be required to make EMF of the hydrogen electrode 0 in pure water at 25 degrees Celsius? Okay, so we need to find the pressure. Clear? So if you know what is the equation, we have 2H plus 2 electrons gives you hydrogen, right? Generally we take pressure of hydrogen as 1 bar, but in the question it is asking exactly what should be the value of the pressure, so that the E naught of the cell should be 0 at pure water 25 degrees Celsius. Okay, so I'll first write the Nernst equation. E of the cell is equal to E naught, right, minus 0.059 by N. So I'll put 2 log of H2, or I'll put the pressure of H2 which we have to find out, divided by H plus square, right? Now here is a catch that you should be knowing. At pure water, okay, at pure water or at 25 degrees Celsius, for pure water, the concentration of H plus and OH minus is 10 to the power of minus 14. Ma'am, what is this? Where did we study this? Can you recall? We have studied this in the chapter Ionic Equilibrium of class 11. And if you have done my bridge course, you would have, like if you have done class 11 and if you have studied from class 11 equilibrium chapter, you will be knowing this one. Okay, so what you should be knowing? So what is then H plus concentration? 10 to the power of minus 7, right? So here I'll put this value. So we note for hydrogen electrode this is 0, and it is also asking that the EMF of the hydrogen electrode should also be 0, means this EMF also has to be 0. 0.059 by 2 log of P of H2 by 10 to the power of minus 7. 7 into 2 minus 14. Okay, now I'll solve this one. If this 0, everything I'll get. So what will be on this side if I just start solving? Just a minute. Okay, so I'll get log of, okay, log of P pressure of H2 by 10 to the power of minus 14 is equal to 0, right? So if this is there, then I can write that P of H2 by 10 to the power of minus 14, I'll take anti-log, that is 10 to the power of 0, which is equal to 1. So what is pressure of H2 I'm getting? 10 to the power of minus 14. So the correct answer will be option number A here. Okay, very simple. Yeah, this question, what was the catch part? You should be knowing this concentration. Okay, how to find the H plus concentration in this question. Moving to the question number 9 here, the EMF of the cell, this is actually TL, okay, thulium, TL to TL plus and Cu2 plus to Cu is 0.83 volt at 298 Kelvin. It could be increased by, okay. So if I just write the equation, okay, so what will be the reaction at anode? Anode reaction, oxidation, this one is undergoing oxidation, so TL is getting converted to TL plus by the loss of 1 electron. Okay, then I have at cathode. At cathode, what is the reaction? I have Cu2 plus 2 electrons gives me Cu. Now you can multiply this with 2, right, to have a same number of equation. So what will be the reaction here? E of the cell will be equal to E naught minus 0.0591 by N log of, if I add these two equation, Ti plus will be in the numerator side, or just let me add it for you. So I have TL plus Cu2 plus gives 2 TL plus Cu. Okay, so what I have? TL plus ions in the numerator with 2, then I have copper 2 plus ions, right? So if I want to increase the E naught value. So I have taught you this many times. If you have to increase the E naught value, copper 2 plus concentration should be increased. If copper 2 plus is increased, then what will happen? This number will decrease. Or Ti2 plus should be decreased. Then also this number will decrease, right? Increasing concentration of Ti plus, increasing will not do, because if I increase the numerator, this whole number will increase, then you are subtracting a bigger number, right? So this one will not there. Increasing the concentration of both, that will also not work. Decreasing the concentration of both, no. Increasing the concentration of copper 2 plus ions, yes. If I increase this one, what will happen? The denominator is increasing, the fraction will decrease. The log of that fraction will decrease. The whole number will decrease. You are subtracting now a smaller number, right? So that is why E naught value will increase. So option number D is the correct answer here. Moving to the 10th question. So this is a NAT type question where you have to find the numerical and then you have like the nearest integer for the question and you have to answer. Okay, you have to solve this question. So the question here is Cr2O7 2 minus plus 6 electrons plus 14 H plus gives 2 Cr3 plus 7 H2O. The reaction was conducted with the ratio of Cr3 plus to Cr2O7 2 minus is 10 to the power of minus 6. The pH value at which the EMF of the half cell will become 0 is. Okay. So first of all, the equation is given. Can I write the Nernst equation for this one? E is equal to E naught minus 0.059. So it is given 0.059, but for easy calculation I'll take 0.06. Okay, then N value is, I'll just put here 0.059 by N log of, this is important. Here you have Cr3 plus square, log of Cr3 plus square divided by, you have Cr2O7 and H plus. So divided by Cr2O7 2 minus H plus, okay, to the power of 14. Okay, this is the equation. Now if I substitute the values, the saying the reaction was conducted with the ratio, the pH value at which EMF of the cell will become 0. That means E is 0. What is E naught value? 1.33 minus 0.06 divided by N value is 6 here, log of, what is this ratio? Cr3 plus square to Cr2O7 2 minus, that is 10 to the power of minus 6, and then I have H plus to the power of 14, right? Now if I want to find out pH, what will be its value? Or pH will be equal to minus log of H plus. Okay, so I want to bring this minus log of H plus to one side and I have to solve all other things on the other side. So what I can do is this, if I cancel, it will become 0.01. Okay, next what I can do, I'll just take this whole term to this side. So I'll get log of, I'll take 0.01, okay, 0.01 log of 10 to the power of minus 6 by H plus to the power of 14 is equal to 1.33. Okay, now you can divide this one. This is 10 to the power of minus 2, right? So that I can divide here. So and I'll expand this one also. So I'll write log of A by B is what? Log of A minus log of B is equal to 1.33 divided by 10 to the power, so this is 10 to the power of minus 2 divided here, it will go up, so it will become 10 to the power of 2, or I can write it as 133. Okay, I'm writing it as 133. Now let's solve this one. Log of 10 to the power of minus 6, right? So this minus 6 will go here, so I'll just put a line here. So I'll get here minus 6, okay, minus 14 log H is equal to 133. Okay, are you getting this one? Log of 10 to the power of minus 6, that will become minus 6. Then I have minus, this 14 can come here, log H. Okay, now what I can do, just take this 6 to that side. Okay, so I'll get 133 plus 6. So I'll have 14 log H plus is equal to 133 plus 6 is 139. Okay, minus log H plus is equal to 139 by 14. Or I can write pH is equal to, you can see 139 by 14, almost it is 140. 140 by 14 is 10, right? So the nearest integer you will get here is your 10. What is the answer for this question? 10. Okay, so this is also very simple question, but yes, a bit of calculation is there. Okay, next, moving to question number 11. Consider the following electrochemical cell at standard condition. You have been given Au is a solid or an inert electrode present, QH2 to Q, then we have NH4X, the NH4X concentration is given, Ag plus to Ag, E cell is given. The couple QH2Q represents queen hydron electrode, the half cell reaction is given to you. E naught value for Ag plus to Ag is also given. The pKb value of ammonium hydride is. Okay, so in this question, if you try to solve this question, how we can do is, see, we have to, if I just talk about the reaction here, so what is the reaction that is happening at anode? So the anode reaction, okay, I'll write at anode, what is the reaction? QH2, okay, this reaction, QH2, yes, this is 2 plus, right? Okay, it gets converted to Q, okay, plus 2H plus by losing 2 electrons. Okay, so that is what we have got. And what is the reaction at cathode? Simple reaction, we have Ag plus 1 electron gives Ag, and you can make it 2 to balance the number of electrons used. Okay, so now what we can do is, we need to find the E naught of this cell. Okay, so if I just add this reaction, what will happen? I'll get QH2, okay, then I'll get 2Ag plus, okay, then you have 2 electrons will get cancelled. You have Q plus 2H plus 2Ag. Okay, that is there. Now the question here is, why are we doing this? Okay, so we need the pKb value for the ammonium salt. So just follow with me for some time, you will get to know why we are doing this. So first of all, I have written from this equation the final equation of the reaction. Now let me just calculate the E naught of this cell. E naught value, it will be cathode minus anode. So which is my anode? Sorry, cathode is silver. Silver electrode potential is 0.8. And what is anode value? This is 0.7. So that is equal to 0.1. Okay, so for now we have known what? The E naught value and the reaction. Okay, so now can I write the Nernst equation? So please, I'll writing the Nernst equation, I'll erase this part. I'll only keep the final part. So I hope you have written the final equation. Okay, if not, please go back and write it. This is my final equation. So can I calculate the E value here? E naught value minus 0.059, okay, it is given to take as 6, so I'll take 6, electrons used were 2, 0.059 by n log of, what is the product ion? H plus square divided by the reactant square, which is Ag plus square. Okay, so this is my Nernst equation. Now let me just substitute. So this work is also done. I have kept this to write the Nernst equation, that also I am done. Now E naught value is 0.1 volt, so that also I am erasing now. I'll directly substitute now. So E naught value is 0.1, okay, and you have been given with E's of the cell is 0.4. So just a minute. Yeah, so I have 0.4, 0.1, 0.03, 0.03 log of H plus square. Now Ag plus, if you see, its concentration is 1 molar, okay, so we don't have to worry about that. This 1 molar, it will become 1 molar square 1 only. So I have done this one. So what is now I can do here is I'll subtract this one. 0.3 is equal to minus 0.03 log of H plus square. Okay, so now what I can do, I can divide this one. So I'll have 0.3 divided by 0.03, then I have minus 2 log of H plus. Okay, so I will have 3. So if I solve this, I'll get 10, and if you divide this one, I'll get 5. So 5 is equal to minus log of H plus, or that is equal to pH is equal to 5. Okay, but the question is not ended here. It is just to calculate, we have just calculated the pH from here, but our task is to find pKb. Now for a salt, okay, for a salt like this, for a salt of weak base and strong acid, we have the formula from salt hydrolysis. pH is equal to 7 minus half pKb minus half log of C. Okay, now where have we studied this one? This we have studied again in the chapter ionic equilibrium under salt hydrolysis. Okay, so now can I get, so I have this pH value, I have C. What is the concentration of the salt? 10 to the power of minus 2. I have this value, I have this value. Only need to think to find out is pKb value, or this pKb value. Okay, so can we do that? So I'll erase this everything. Okay, so I'll erase this one, and now we will do that calculation. And remember, what is the value of pH I have got? pH value I have calculated is 5, right? So let's solve this one then. So we have, okay, pH value is 5, okay, is equal to 7 minus half pKb minus half log C value is how much? 10 to the power of minus 2. Okay, now this one is 5 equal to 7 minus half pKb, then I have minus, this minus, it becomes plus, so it will become plus 1, right? So this minus 2 comes here, minus minus, it becomes plus 2, 2 by 2 becomes 1, and log 10 is 1. So now I have here, so I have, okay, I can solve this one. 7 plus 1 is 8, right? So I have 5 is equal to 8 minus half pKb, or I can write half pKb is equal to 3, or pKb will be equal to 3 into 2, that is 6. Okay, pH is equal to 7 minus half pKb minus half log C. Yes, so what is the answer I am getting? The nearest integer will be 6. Okay, so that will be the value. Moving to the next question, that is question number 12. The hydrogen electrode is dipped in a solution of pH 3. The potential of the electrode will be, okay, so again this is very simple question. We have this equation, 2H plus 2 electron gives me H2, right? Then what is the E naught value? I have to find E value. E naught value minus 0.059 by N log of, right, the H2 will take, as if it is nothing is mentioned, you can take pressure of H2 as 1, and then you have H plus concentration as square of H plus, right? So how much will be this one? So now if pH is equal to 3, right, so what is the relation? pH is equal to minus log of H plus, right? pH is equal to 3 minus log of H plus. That means minus 3 is equal to log of H plus. That means H plus, you have to take anti-log, that is 10 to the power of minus 3. So what is this concentration of H plus? 10 to the power of minus 3. So let us now substitute. We have to find this E value. E naught value, I know it is 0, and this one I will take it as 0.06. 0.06 divided by 3 is 0.03 log of 1 by, what is this value? 10 to the power of minus 3 square. Okay, so that will give me 0 minus 0.03 log of, it goes up 10 to the power of minus 6, it goes up, it will become 10 to the power of plus 6, right? Yes. Next I will have here 0 minus 0.03 into 6 log of 10 to the power of 10, log of 10. So this 6 came here, log 10 value is equal to 1. So now I will have minus 0.18, right? So what will be it? This is given dash into 10 to the power of minus 2. So can I write it like minus 18 into 10 to the power of minus 2, right? So that is why what will be the nearest integer here? Minus 18. Okay, so simple question, but the only thing is need to be little bit careful about the calculations. Okay, let's move to the next question here. The potential of the given half cell at 298 Kelvin is dash into 10 to the power of minus 2. You have been again with the hydrogen cell and the pressure this time is different. So fine, we are not worried, we can easily do this. E of the cell is equal to E naught minus 0.059 by N log of pressure of H2 divided by H plus concentration to the power of 2, right? So we have to find the potential of the half cell. So I have to find E value. Now E naught value for hydrogen is 0. Now this one is given to me to consider 2.303 RTS 0.06. So I'll make it as 0.06. Now N here is 2. So this one 0.06 by 2 is 0.03. Then I have log of, what is the pressure of hydrogen? Pressure of hydrogen given is 2. H plus concentration, how much? 1 molar, right? So this is 1 molar to the power of 2. That also I am not that much worried because this is 1. So I have minus 0.03 into log 2 value is given me as 0.3. So that will give me 3 3s are 9, but I have 3 decimal places, right? Or I can say that, but this is in terms of 10 to the power of minus 2. So can I write 0.9 into 10 to the power of minus 2, right? Then 0.9 can be rounded off to 1 into 10 to the power of minus 2. So you have to write the nearest integer. So what is the nearest integer here? 1. 1 into 10 to the power of minus 2. Clear? So the answer here will be 1. Okay. Moving to the question number 14 here. Consider the following redox reaction. The standard reduction potentials are given. If the constant of the above reaction is given as K equivalent equal to 10 to the power of X, then find the value of X. Okay, so this is from your equilibrium constant formula. So what is there? We have learnt E of the cell or E naught of the cell is equal to 0.059 by N log of K, right? So first let us find the E naught of this cell. So you can see here MnO4 minus is plus 7 and Mn is plus 2, right? So I'll write the reaction here, anode reaction. So MnO4 minus to Mn 2 plus. So plus 7 to plus 2, it will lose 5 electrons, right? Then if I have cathode, for cathode you have C2O4 2 minus, okay, what's the oxidation state here? Plus 3, and here it is plus 4, right? So plus 3 to plus 4, it has only 1 electron, right? Or it is a, I can say, gain of 1 electron, but there are 2 carbons, so total there will be a gain of 2 electrons, right? But here it is 5 electron, here it is 2 electrons, so we should multiply. This equation is multiplied with 5, this equation is multiplied with 2. So what is the thing here? The total electrons I will require is 10 in this reaction. So what is the N value I need to find? That is 10. And which is my cathode? This is my cathode. 1 second, I did a small mistake. Okay, I did a small mistake here. This cathode and anode I have exchanged, right? Just a minute. Yeah, so here I have done a mistake. Okay, So okay, so plus 7 to plus 5 is reduction, right? So this is my cathode. Okay, and I have plus 3 to plus 4 is oxidation, so it will lose 2 electrons, so this is anode. So this equation anyway you will multiply with 5 and this you will multiply with 2, so n value will remain 10. Now we have to calculate E naught. So how to calculate E naught? Cathode minus anode. So cathode is your manganese, that is 1.51 minus this is minus 0.49. Okay, so I'll have 9 plus 1 10, 5 plus 4 9 plus 1 10, then I'll have 2 volt, right? So I'll get this one as 2, and I'll take 0.059 by 10 is equal to log of K. Okay, now we can easily solve this. I'll have 20 by 0.059 is equal to log of K. So can I just solve this and find the value? So I'll erase this side, okay, so that I can calculate this value. Okay, just a minute. Okay, so we will solve this, but we can do a small bit of rounding here also, so that we can get a easier number to calculate. I'll do it 0.06. So I have 20 divided by 0.06, okay, is equal to log of K, or I'll write 20 by 6 into 10 to the power of minus 2, okay, or I can write 20 into 10 to the power of 2 divided by 6. Okay, so I'm just doing to simplify the calculation, right? Or I can write 2 divided into 10 to the power 3 divided by 6. So I have 1 by 3. So I have 1000 divided by 3. So 1000 divided by 3. So if you know this number is very common, we divide it many times. So we will get 333.333. It will continue, right? So what I'll get here? I'll get log K is equal to, or 1 second, what if I find? So now I have to find the log K value, or I have to solve this number. So can I write this one as 20 divided by 59 into 10 to the power of minus 3 is equal to log of K, right? So that will give me 20 into 10 to the power of 3 divided by 59 is equal to log of K, right? So let me just try to solve this. 20 divided by 59, right? So I'll put a decimal and this one, and I'll go for 3, right? 3 9s are 27, 15, 6. 3 9s are 27, 15, 16, 17. Then I have 10 minus 3, 7. 9 minus 7, 2. Then I have this one, and I have then 4 9s are 36. 4 is not there. Again I have to take 3. So I have 177. Okay. Then I have, yeah, again I'll take 530. Now 530, when it has come, we have to be very careful. 6 9s are 50, I can take 8. 8 9s are is 72. 8 5s are 40 plus 7 47. Can I take 9 also? 9 9s are 81. 9 4s are 45. 45 for 9. No, I'll take 338. Next I have 8 9s are 72. 7. 8 5s are 40 plus 7 47. I have 10 minus 2 8. 12 minus 7 5. Then I'll have one more 580. So again I think I'll be taking 8. 8, right? So now if you see, we have 3388. Then this is 20 by 59, right? 3388. So I'll just erase this one. So what I will get here, see this part, that is this 20 by 59, I got 3388 into 10 to the power of 3, that is equal to log of K, right? So that is equal to 338.8 is equal to log K, or can I write 339 is equal to log of K, or can I write K is equal to 10 to the power of 339. So what is the X value? X value is 339. Okay, so this was a 2024 question. I know a little bit of calculation is involved, but yes, not a difficult question. Okay, next students, let's move to question number 15 here. The standard reduction potential at 298 Kelvin for the following half cell reactions are given below. Okay, consider the given electrochemical reactions, the number of metals which will be oxidized by Cr2O7 in aqueous solution is. So, which will be oxidized by Cr2O7 means Cr2O7 will oxidize the other metals, means itself it will undergo reduction, right? So, those metals which cannot undergo reduction, that will be oxidized by Cr2O7. Okay, so see here we have Fe3 plus, Ni2 plus, Ag plus and Au3 plus, and I have Cr2O7. So if Cr2O7 has to oxidize these metals, that means itself it will undergo reduction and these metals should undergo oxidation. So the reduction, suppose if I compare Cr2O7 and Fe3 plus, Fe3 plus reduction potential is less, Cr2O7 reduction potential is more, so Cr2O7 will undergo reduction and it can oxidize Fe3 plus, right? So it can oxidize Fe3 plus, yes. Now let's consider nickel. Nickel reduction potential is also less, so that means in case of chromium and nickel, chromium will undergo reduction or chromium can oxidize nickel 2 plus. So nickel will undergo oxidation and chromium will be undergoing what I'll say reduction. Next we'll have Ag plus and Ag. Here if you see, here also the reduction potential is less, that means Cr2O7 will undergo reduction, right? That means it is getting it will be undergoing reduction and this metal will undergo oxidation, so that also will happen. But if you compare this one and this one, Au is having more reduction potential, right? So that means Au will undergo reduction here and it will not oxidize this one because this one itself is undergoing reduction, right? It is not undergoing oxidation. So that is why we have 3 metals here and the answer is 3. Okay, these 3 metals will be oxidizing Cr2O plus because they are undergoing oxidation. Okay. Okay, next we'll see question number 16. So we'll go to the next part of the topic, that is conductance of electrolytic solutions, electrolytic cell and electrolysis. Okay, so given below are 2 statements. So we have Ag plus, Hg2 plus, Cu2 plus and Mg2 plus reduction potentials are given. And you have a solution of copper nitrate, silver nitrate, mercury nitrate and magnesium nitrate. With the increasing voltage, the sequence of deposition of the metals on the cathode will be Ag, Hg and Cu. So if you see the reduction potential of Ag is maximum, so that will be deposited first, then we have Hg and then we have Cu. So yes, this order is correct. Okay, so statement 1 is definitely correct. Magnesium will not be deposited at cathode. Instead, oxygen gas will be evolved at cathode. So magnesium reduction potential is very low, so it will not undergo reduction at the cathode. But then which one will undergo? H plus ions will undergo reduction because if you have taken aqueous solution, H plus will be reduced and hydrogen gas will be produced, not oxygen gas. So this is wrong. So statement 1 is correct but 2 is incorrect, which is option number B. Okay. Moving to the next question, 17th one, the correct order of limiting molar conductivity for cations in water at 298 Kelvin is. So here is little bit of trick. First of all, the size matters, okay, and the charge also matters. So basically first, but H plus is a one which is having the highest molar conductivity, so H plus has to be at the top, so we can eliminate these 2 options. And after that, charge matters. So we have calcium and magnesium 2 plus charges, these are maximum. After that we have +1 charges. So B is the correct answer, and I'll give you the detailed values also. You can see here H plus is having 350, Na plus is having 50, K plus is having 73, Ca2 plus is 119 and Mg2 plus is having 106 molar conductivity. Okay. Moving to question number 18 here, which of the following electrolyte can be used to obtain H2S2O8 by the process of electrolysis? So if you have seen my lecture on products of electrolysis, there I have told you that concentrated solution of sulfuric acid will obtain H2S2O8. So that is why B is the correct answer. Okay, please see the lecture, you will get it. Next we'll go to question number 19 here. A solution of aluminum chloride is electrolyzed for 30 minutes using a current of 2 ampere. The amount of aluminum deposited at the cathode is. This is very simple and direct question. We'll use Faraday's law. M is equal to Z into I into T, where Z is equal to what? Molar mass by N into 96500 into I into T, right? So aluminium 3 plus, how will it get deposited? You have aluminium 3 plus 3 electrons gives me aluminium, right? So what is the molar mass here? 27. The N value is 3 and I have 96500, right? What is the current I have? Current is 2 amperes. Time we have is time is given 30 minutes or 60 seconds, right? So I can cancel these 2 zeros and these 2 zeros. I can further cancel 3 ones are 3 nines are, right? So I have 9 twos are 18. So I have 18 into 18 divided by 965. 18 square, have you remembered? 324 divided by 965. So we'll just check the first number and then we'll be able to do it because the options are very different. So I have 324 divided by 965. So I'll just take this 0. Then I think 3 5s are 15, 18, 19, 27, 28. So 0.3 will work. So I have only one option with 0.3. So that is why option number C here. You don't have to do the full division. Moving to question number 20. Okay, so the molar conductivity of a weak electrolyte when plotted against the square root of its concentration, which of the following is expected to absorb? So if you remember, I have discussed for weak electrolyte, the graph is like this, right? This side we have molar conductivity and this side we have concentration. So the molar conductivity decreases sharply. Molar conductivity decreases sharply with the increase in concentration. So if I see here, okay, so molar conductivity decreases sharply with the increase in concentration. Yes, this is correct according to the graph. A small increase in the molar conductivity is observed at infinite dilution. Is there a small increase? No, we observe a major increase in the molar conductivity. So this is wrong. A small decrease in molar conductivity is observed at infinite dilution. No, there is no decrease. When we decrease the concentration, molar conductivity increases. Molar conductivity increases sharply with the increase in concentration. No, molar conductivity increases sharply with the decrease in concentration. So molar conductivity decreases sharply with the increase in concentration. When you increase the concentration, molar conductivity decreases sharply. So that is the correct statement, option number A here. Moving to question number 21 here. This is also a very good question. The molar, okay, really sorry students. Okay, let's move to the next question here. The molar conductance at infinite dilution of ammonium chloride was found to be 185 centimeter square mole inverse. Whose? Ammonium chloride, right? Molar conductivity of ammonium chloride at infinite dilution is 185, okay, which is equal to the molar conductivity of NH4 plus and the molar conductivity of Cl minus. Right, we got this one. Next what I have, the ionic conductance of the hydroxyl and chloride ions are 170 and 70. So I have the ionic conductance of hydroxyl ion and chloride ion are how much? 170 and 70. Okay, I am not writing the units are there. Next, if the molar conductance of 0.02 m solution of ammonium hydroxide, so I have been given with molar conductance of ammonium hydroxide, how much? 85.5. okay, then its degree of dissociation given by x into 10 to the power of minus 1, degree of dissociation. So if I want to calculate the degree of dissociation of ammonium hydroxide, what all value I need? I need the molar conductivity of ammonium hydroxide by the limiting molar conductivity of ammonium hydroxide, right? For limiting molar conductivity, I know this value, which is 85.5, but for this you need NH4 plus ions and OH minus ions. OH minus ions is already given. Can I calculate NH4 plus ions from here? Yes. How can I do that? See, so I can write here lambda of NH4Cl is equal to plus lambda of Cl minus. Now what is NH4Cl value? 185. Okay, then I have, and Cl minus is 70. Then if I take this 5 minus 0, 5, 8 minus 7, 1, 1, NH4 plus, right? So this is 115, and what is OH minus? 170. So can I calculate for NH4OH? This is 170 plus 115, 285. Okay, so this gives me, so what is this value? 85.5, and this gives me 285. Okay, so if I solve this, so if I see 3 5s are 15, 3 8s are 24 plus 125, so this one will be, I can just write it as 0.3, right? So 0.3, so that means I can write 3 into 10 to the power of minus 1. What is the nearest integer value? Here the value will be 3, right? Okay, next moving to question number 22, we have batteries and fuel cells. So on charging the lead storage battery, the oxidation state of lead changes from X1 to Y1 at the anode. So if you remember, before what happened at anode, what was the reaction going on? Pb got converted to PbSO4. This was the reaction at anode. And what was the reaction at cathode? At cathode, PbO2 got converted to PbSO4, right? So I have 0 to plus 2, and here I have plus 4 to plus 2. This was when the reaction was discharging. This was when we were discharging, right? Now what will happen? When you are charging it, reverse reaction will happen. So at anode, what will happen? Plus 2 to 0 will change, right? So at the oxidation state of lead changes from X1 to Y1 at the anode. So at anode, plus 2 to 0. This reaction is happening now. Plus 2 to 0. And from X2 to Y2 at cathode. So plus 2 to plus 4. X2 to Y2 at cathode. Plus 2 to plus 4. So what is this value? Plus 2, 0, plus 2, plus 4. That is option number B here. Next we have question number 23, very easy question on the basis of uses and all. So first of all, which I know, Apollo space trip, very famous. I have told you in Apollo space program, hydrogen fuel cell was used. So D will be 2, and I can see that there is only one option with D2, so that has to be option number A. But let's check. Transistor, we have zinc and carbon electrode, that is your Leclanc cell, and in hearing aids we use zinc mercury cell, so B has to be 1, and in inverters we can use lead, so that is C4. Okay, clear? Very easy question. Next we have the metals that are employed in the battery industries are. So which all metals we have seen? Iron we haven't seen. Manganese we have seen, yes. Nickel cadmium battery we have seen. Chromium we haven't seen. Cadmium, yes, we have seen. So manganese, nickel and cadmium, B, C, E. We have any option like that? B, C, E, yes, option number E, right? B, C, E are used in the battery industries. Next, fuel cells using hydrogen and oxygen as fuels has been used in spaceship. Yes, A is correct. Has an efficiency of 40% to produce electricity. No, they have an efficiency to produce 70%. So B is not there. Use aluminium as catalyst? No, they use platinum and palladium. Is eco-friendly? Yes. Is actually a type of galvanic cell? Yes, because here it is also, but the only difference is instead of a redox reaction, here a combustion reaction is used, right? So that is why this is A, D and E, which is option number D, right? So we have solved 25 questions covering all the topics. So I hope you have enjoyed the session. But here the catch is there that I have a brainstorming session for all of you. So I have given you a homework question to try this one. O2 gas will be evolved as a product of electrolysis in which of these options? Okay, so please try this question. You can go and refer and read about it and then come back, and then you can put down in the comment section what will be the answer for this question. And remember, the person who answers correctly, the student who gives me the first comment, will definitely be recognized in the next video. Okay, so please try answering this question. Very simple one. Just take some time and don't copy it at all. Okay, so students, I hope that you have enjoyed the session, and I think the questions were quite interesting. You were able to solve it if you have done the KCET lectures properly. So there is nothing that if we have studied for KCET we can't do JEE questions at all. You can do. You need to just keep updating yourself, practice as many questions as possible. Okay, so my dear students, I hope your preparation is going smoothly. You are consistent with your preparation. So please, if you have any concerns, do reach out to me, put down in the comment section. I will be answering to all your questions. Okay, so and I know some of you have requested for many videos for strategies planning. We are planning out on that. We are working out on that. So we will be definitely doing this. And one more important thing, that tomorrow, that is on Saturday, we will be having a live quiz on the chapter solutions. So please prepare the chapter properly and come tomorrow to see who is top in the leaderboard. Okay, so this is just a hint. Today you will be having, I think you must have already completed the Jasmine Mam's bio live quiz. So in tomorrow's class we will be having chemistry's live quiz. Okay, chapter solutions, right? So that's all in this video, students. Thank you for watching, and keep learning and keep smiling.